processes. Well, as it turns out, that's also the same narrow part of the spectrum that is the most informative about the various structures that we discover in the universe around us.
These specific frequencies that enable plants to manufacture food and astronomers to observe the cosmos represent less than 1/1,000,000,000 of a trillionth of the universe's range of natural electromagnetic emissions. Fortunately, it is the type of light our sun produces in abundance, and that most easily penetrates the filtering shield of our atmosphere to reach the surface of the Earth.
It's a remarkable coincidence that the kind of atmosphere that's needed for complex life like ourselves does not preclude that life from observing the distant universe. It's a surprise. It's something that you wouldn't expect just chance to produce. Why would the universe be such that those places that are most habitable also offer the best opportunity for scientific discovery?
In 1997, Guillermo González began a study of the Earth's specific location within the Milky Way galaxy. It would eventually lead him to more evidence of a correlation between life and discovery.
Just as our location in the solar system is optimized for habitability, so is our location in the galaxy. We inhabit a spiral galaxy, which means it's highly flattened. It has a spherical bulge in the center, and it has spiral arms. And we live about halfway between the center of the galaxy and the edge.
Working closely with astrobiologists Peter Ward and Donald Brownlee, González compared our position in the Milky Way to other regions within an often hostile galaxy.
The galaxy has a lot of dangers. And perhaps the most dangerous place in the galaxy is the galactic center.
Well, in the center of the galaxy, this density of stars is very high, and there are more supernovas and stuff. And there are things that could harass life right in the dead center regions of our galaxy.
We also have the giant black hole at the very center of the galaxy. And if it were to have a close encounter with a star passing near it, it would rip it to shreds and form an accretion disk around it and emit lots of radiation, particle radiation, and electromagnetic radiation, gamma rays, X-rays.
While a black hole, exploding stars, and deadly radiation would make complex life virtually impossible near the galactic core, the outer edge of the Milky Way poses other challenges to habitability.
In the outer regions, the situation is much more subtle. We live on a planet made out of iron, magnesium, and silicon, and oxygen. If we went in the more distant regions of our galaxy, out towards the outer edge, the abundances of these elements are lower.
There probably aren't enough heavy elements to build Earth-sized planets that can support life. So there's a happy median between the dangerous galactic center and the outer edge of the galaxy.
González, Brownlee, and Ward labeled this region, where complex life is possible within the Milky Way, the galactic habitable zone. Their theory was first published in 2001 and has since received growing acceptance among astrobiologists.
There's a lot more research that needs to be done to determine just how wide the habitable zone is, but I think there's general agreement that yes, there are definitely places in the galaxy that you cannot have civilizations because they're very dangerous, and there are places where you just have a very low abundance of heavy elements.
While these obstacles to habitability are minimized far from the core and edge of the Milky Way, González has also identified large areas within the galactic habitable zone itself, which are less hospitable to complex life.
Even within the habitable zone in the galaxy, it's broken by the spiral arms, which are dangerous places. That's where most of the supernovae go off in the galaxy. That's where the star formation is taking place.
We don't want to be too close to a spiral arm. We want to be outside the spiral arm at about the right region of the galaxy.
It appears this is precisely where the Earth is located, in the relatively safe and uncrowded region between the Sagittarius and Perseus arms of the Milky Way.
location is everything. And so we occupy that special place in the galaxy where habitability is optimized, threats are minimized, and we have enough building blocks to build an Earth.
Guillermo Gonzalez and Jay Richards have conducted research on another facet of the galactic habitable zone. They now argue that the Earth is also located in the best setting within our galaxy for astronomical research.
As it turns out, our position in the universe is not only critical for life, but it's also surprisingly important for making scientific discoveries. We're located near the midplane of the galaxy, a very highly flattened galaxy, between spiral arms in a region with very low dust extinction. While we are in the plane of the galaxy, that does not obscure a large part of the sky, so we can have very clear views.
For more than a century, this nearly ideal platform of observation has enabled astronomers to study the structure of the Milky Way. Looking toward the constellation Sagittarius on a clear night, for example, we see that the stars in our galaxy are not uniformly distributed across the sky. Instead, they appear as part of a concentrated band, a flattened disk of stars, dust and gas, 100,000 light-years in diameter.
The Milky Way band in the night sky is us looking edge-on into the plane of the galaxy. If we were living in the center of the galaxy, things would look much more spherically distributed. And so it will be very hard to distinguish things that are inside the galaxy from things that are outside. And it's also very dusty, much dustier towards the galactic center than it is in our region. And so the views of the distant universe will be much more difficult to obtain. They'll be much more compromised.
Similar problems would exist for astronomers working on a planet located within any of the galaxy's spiral arms. Here, denser concentrations of dust clouds and gas illuminated by stars would make it difficult to determine the shape of the Milky Way, or to distinguish the stars in our galaxy from the rest of the universe.
On the surface of the Earth, we're really in the optimum position for seeing both the nearby structure of the Milky Way galaxy as well as seeing the distant cosmos as a whole. So once again, we see that the best location for habitability and for producing a habitable planet is also the best overall position for scientific discovery, in this case, at the galactic scale. For centuries, the fact that we can discover things about the universe has really been something of a mystery. Why would beings like ourselves be able to discover a universe like this? Why is what we think about the universe, why would it correspond to the way things really are?
Our ability to discern and understand the universe is a fundamental part of what makes the universe tick, so that we're linked into it. This isn't just a sort of an accident, a trivial little byproduct. It is something that is linked to the great cosmic scheme of things. Now, I've no idea how that linkage works, why it's there, or anything of that sort, but I'm very, very struck by the fact that we can understand the universe in such exquisite detail and at such a deep level.
The spectacular progress of modern astronomy and physics is the product of a universe accessible to the human eye and mind. It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together to allow for both complex life and scientific discovery.
If you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light. And the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
If you're to take the basic fundamental constants of nature and you were to change these even slightly, or you were to pick their values at random, you would almost never get a universe that would be habitable in any sort of way. That is, you couldn't have galaxies, you couldn't have planets, you couldn't have complex biological organisms if these fundamental constants were even slightly different, slightly stronger, slightly weaker than they actually are in this universe. That's the idea of fine-tuning.
To better appreciate this concept, imagine a machine able to control the strengths of each of the physical constants. If you changed, even slightly from its current setting, the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
If you increased it by a little bit, no large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
Now, this is one of a long list of properties in underlying physics that seem to be prerequisites for a universe with life. For example, the strengths of the other forces are all important, the masses of the various subatomic particles. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
These forces and constants are another example of the correlation between life and discovery. For not only are they finely tuned for our existence, they can also be understood.
It's remarkable how well the laws work. And not only that, it's remarkable how simple they are. And that also is related to the discoverability of the laws.
Albert Einstein wrote, "I have deep faith that the principles of the universe will be both beautiful and simple." For nearly 400 years, scientists have discovered an elegant simplicity in the mathematical equations that express and unlock the laws of the cosmos.
It's been said that many of the most important theories in theoretical physics can be written on a single sheet of paper. And this, I think, ought to be considered surprising, that such a simple formula or equation could have such far-reaching applications to a very complicated and very large universe.
What you have is a universe that is not only finely tuned for life to occur, but also has a beautiful, elegant mathematical structure, and a structure such that we can discover that structure.
Most scientists just take it for granted that the world is both ordered and intelligible. And the intelligible part I find really quite extraordinary, because it's one thing to accept that the universe is ordered, but ordered in a way that human beings are capable of understanding is an extraordinary thing. And so the question naturally arises, what is the explanation for that?
Many who have pondered this mystery of an intelligible universe argue that it cannot be easily explained away.
From naturalistic assumptions, you would not expect the universe to be understandable by human reason. After all, within the standard naturalistic story, human reason was developed to be able to hunt prey, get around in the everyday world, attract mates.
We have certain skills, for example, we can jump streams and catch falling apples and so on, which are necessary to getting by in the world. But why is it that we also have the ability to discern, for example, what's going on inside atoms or inside black holes? These are completely outside the domain of everyday experience, totally surplus to requirements, not at all necessary for good Darwinian survival.
The discoverability of the universe is something we didn't need for our existence. It's something additional to it. It seems then that whatever the source of the universe is, it intended that it contain observers who can discover.
You put observers in the best places for observing. That is, if you're going to do things intelligently, that's what you do. The nature of our planet, the nature of its atmosphere, the location in the solar system, the type of solar system it's in, even the type of star that we're around and the location within the galaxy are optimal for making a wide range of scientific discoveries. It turns out that those are also all the most important conditions for a habitable planet. That is, for a planet that's conducive to beings like us and without which we could not survive. I think that's just the sort of pattern that ought to suggest to people conspiracy rather than mere coincidence.
There's something about the universe that can't be simply explained just by the impersonal forces of nature and atoms colliding with atoms. And so you have to reach for something beyond the universe to try to account for it.
Such an approach lies at the foundation of modern science. In his search for a more elegant description of the solar system, Nicholas Copernicus was motivated by his desire to comprehend what he called the mechanism of the universe, wrought for us by a supremely good and orderly creator. The system, the best and most orderly artist of all, framed for our sake.
And so he imagined this analogy of a workman, a craftsman, making something that worked well and was beautiful. And that analogy, it wasn't one of his conclusions. That analogy was one of his assumptions.
The founders of modern science, like Copernicus and Kepler and Galileo and Newton himself, believed that the universe was the product of a mind, that it was intelligible to beings like ourselves because the universe itself was the product of an intelligent being.
They were driven by this notion that this was essentially a theological quest. They were uncovering God's handiwork in the way the world works. I mean, what a thought that we can glimpse the mind of God. We can actually figure out how God put the universe together. So there's a hidden subtext in nature which can be exposed through this procedure we call science.
Though most scientists no longer think in such explicitly theological terms, recent evidence may again point to an Earth far different from the contemporary image of a pale blue dot lost in a cosmic sea.
We've often been told, especially in the 20th century, that the universe does not have us in mind. That is, that we exist in a very large universe and that the universe was not designed for beings like us. We are simply life that happened to come about on a tiny little planet surrounding a tiny insignificant star in a run-of-the-mill galaxy within a very large universe that was not intended. Our argument suggests something completely different. It suggests that the universe was intended, that the universe exists for a purpose, and that purpose isn't simply for beings like ourselves to exist, but for us to extend ourselves beyond our small and parochial home, to view the universe at large, to discover the universe, and in fact, perhaps, to consider whether that universe points beyond itself.
As we gaze ever deeper into the universe, we are inevitably drawn back to timeless questions. What is the source of the cosmos? And what is our purpose within it? While answers will always be debated, valuable new insights are now at hand, emerging from a corner of the universe where complex life and scientific discovery have converged on an extraordinary planet called Earth.